morning, everyone. Welcome to the Perimeter Institute and the Inspiring Future Women in Science Conference. My name is Kelly Foyle, and I'm a physicist, and I'm a member of the Perimeter's Educational Outreach team. It's tremendously inspiring to see a room like this filled with young women who are curious about the world, passionate about science, and eager to make important contributions. We also have additional guests watching online through our webcast this morning. Thank you to all of you for joining us both here in the theater and online. You are the future of women in science, and this conference is about you and for you. I'm really eager to hear your comments and questions throughout the sessions this morning. We are also pleased to welcome Linamar Corporation as the presenting sponsor of this conference. Now, Dr. Rob Myers, Perimeter's director, would like to welcome all of you.
Thank you, Kelly, and good morning to everyone here. Of course, I'm not the person that you came here to see, but I just wanted to take a moment to welcome you all to this year's edition of Inspiring Future Women in Science. It's really one of the favorites here at the Institute, and it's a conference that's important to me. And that's not just because I'm the father of 3 daughters, each of whom has sat out in the auditorium at one of these meetings, just like you are now. But it's important to me because I'm a scientist. This is a time when science and society faces great challenges, but it's also a time of great possibilities. And it's a time when we need all of the ideas. Science will not thrive if we only tap into half of the talent pool. As a mentor to young researchers, I've often noticed that women may not necessarily be the loudest ones in the room, but they have ideas that we cannot do without. And so whether you choose physics or science or something completely different, I encourage everyone here to speak up. The future needs you. And so with that, I'll close and we'll get on to the fun stuff, but just enjoy your day. Thanks.
Thank you, Rob. We have an exciting morning ahead. We are honored to have 20 amazing and inspiring women who have followed a STEM career with us here today, supporting and contributing to this event. Altogether, they represent over 250 years of work experience in their fields. Not to make us feel old or anything. Although they'll make us feel old, hopefully it will encourage you to learn as much as you can as they share their stories on how they pursued their paths and offer you advice and food for thought on your career ahead. In the next few hours, you have the opportunity to learn as much as you can from the experience of women who have come before you. Much of science, too, involves building on the work done before and learning from the experience of others. In the spirit of understanding and learning from what has come before, I would also like to acknowledge that we are located on the traditional territory of the Attawandaron, the Anishinaabe, and the Haudenosaunee peoples. Perimeter Institute is situated on the Haldimand Tract, land promised to 6 nations, which includes 6 miles on each side of the Grand River. As a young woman living in Canada, you are impacted by all that has come before you, but you also have the opportunity to learn from the experiences and perspectives of a truly diverse community. I encourage you to ask questions and remain open to the thoughts, reflections, and wisdom of others while considering your own path for the future. Throughout the morning, we've tried to give you as many opportunities as possible to ask questions and talk directly to the speakers and panelists and mentors. Please make sure to take advantage of this opportunity. Again, this day is about you, so your participation and questions are central to making the morning a success. We'll just briefly go over how the morning will work. Soon we're going to hear from 2 of our 3 speakers. Each will be followed by an opportunity for questions. After the first 2 speakers, we'll have a panel discussion. The panelists will delve into their lives as STEM professionals, but most of the discussion will be driven by your questions. After the panel discussion, we're going to have our final speaker and questions again. And then we're going to say goodbye to our online audience and move to the atrium for a speed mentoring session. This is an opportunity to discuss in small groups with women in a variety of STEM professions. The mentors are excited about sharing their experiences with you. There's a lot ahead, so let's get started. I'd like to introduce you to our first speaker, Linda Hazenfrans. Linda Hazenfrans is the CEO of Linamar. Based in Guelph, Linamar is an advanced manufacturing company combining leading-edge technology with deep manufacturing expertise, and we welcome their ongoing support as the presenting sponsor of this conference. Linda joined Linamar in 1990 and worked her way up from the ground floor, experiencing all aspects of the business, including running a machine, engineering, and operations and management. Linda has earned multiple awards and recognition and is actively involved in many professional organizations. Most recently, she was installed as Western University's 23rd Chancellor. Please join me in welcoming Linda Hazenfrans.
Thank you, and good morning, everybody. It's a real pleasure for me to be here to welcome you to this wonderful conference. I think you guys are really going to enjoy the day. Certainly, we've always enjoyed our involvement with sponsorship of the day. So as you heard, I'm Linda Hazenfrans. I'm CEO of Linamar. We are a global, diversified, advanced manufacturing company. What that means is we're taking all the latest in terms of exciting technology, much of it enabled by artificial intelligence and machine learning that has really come to the forefront over the last 5 or 6 years in particular, and coupling it, as you heard, with our deep manufacturing expertise to really solve problems for our customers and for their customers, whether it's about carbon efficiency and trying to reduce or eliminate emissions in our vehicle business, or finding ways to bring clean water or power to the world. Those are the kind of things that we and other people in the manufacturing world are trying to get done. So I have a prop. I'm going to put it down for a minute. There we go. A little bit of advice I like to give to young people when I get the opportunity to. So you're obviously thinking a lot about what am I going to study? What am I going to do next in my life? And I like to give 3 pieces of advice. Number 1, obviously pick an area of study that is interesting to you, something that you're naturally curious about and that you enjoy learning about. Number 2, do a little research on the kind of jobs that you can do coming out of that area of study, and make sure there's some demand for those jobs. Do a little more research to look at the earnings potential of those jobs and just make sure it lines up with the lifestyle you envision. I feel like that's a good sort of success story, right? So if you can look at something you love, that there's jobs out there and it's got the opportunity that you're looking for. And I feel like science and technology are a great choice for anybody who's obviously naturally curious about the world around them and how it works. There's certainly huge demand for those careers out there in many different industries and great earnings potential as well. So I feel like it really checks all 3 of those boxes. So I know you're thinking, but are there many women in those areas of study? And I can happily tell you that the answer is yes. And the numbers are increasing every single year. We have 20 times the women in engineering and science than we did 25 years ago, and momentum is just continuing to build. I look at the schools around us. The University of Toronto is a great example. They're one of our country's top-ranked universities, and with a world-recognized engineering program, and they are sitting at 42% women in their engineering program. So clearly, things are changing, and it's exciting to see that out there. They're not alone. Other schools, University of Waterloo right here in town, Western University, the University of Guelph, are all seeing higher and higher levels of enrollment of women in their STEM programs. Canadian women aged 25 to 34 hold 39% of all STEM degrees, which is almost parity, which is fantastic, right? Remember, the goal is 50%, not 100%. People throw these numbers out and they say, 30 or 40%, and you think, oh, that doesn't sound very high. But really, your goal is 50, not 100%. So we're actually doing quite well. Women in STEM jobs earn 35% more than their counterparts in non-STEM careers and 40% more than non-STEM men. For that reason, myself and many others believe we should be doing everything we can to try to increase even more the representation of women in STEM. So a great example of that is actually an initiative that we started at Linamar back 2 years ago called See It, Be It, STEM It. And the idea of it was to try to get more young women interested into science, engineering, math, technology through really an extensive role model celebration concept. So we created a website. We have about 150 women profiled on our website today in all kinds of different areas of STEM. I really encourage you to check it out. It's seeitbeitstemit.com. And then, this is where the prop comes in. We have twice so far created these awesome calendars that are showcasing 12 of the women each year to really kind of keep the story going all year long. And it's so great, you know, you read these stories of these women and why they decided they wanted to study STEM and how much they're enjoying the careers that they've gone into, and also really interesting to see all the different kind of careers that you can get into out of your STEM background, not just in science, but in banking, for instance. The banks are hiring huge numbers of engineers and physicists to do all the complex algorithms that they're developing in that industry. So a lot of places you may not have thought that that's the kind of study to do to get into that career. So we have several of these calendars out front someplace, not sure where, but I've got a stack of them that I brought for you guys, so if you want one, grab one and take it home and talk to some of your friends about it. We printed and distributed 20,000 calendars last year, and you know, I'm really excited by the great reception that we're seeing. Now, when I started out in the automotive industry, I was often the only woman in the room, or one of only a couple. But of course, that's really changed as well, thanks in many ways, really, to more women in STEM roles. There's so many more women in senior roles in the automotive industry and all kinds of other industries where they may not have been represented before, in both the automaker and on the supplier side, including, in fact, the CEO of one of the world's largest automakers, General Motors. So I personally felt like the lack of women at the time in the industry was never an issue for me. And I think that's probably because I just didn't let it be an issue. And that's another little bit of advice that I have for you, is to not dial into negative frequencies, let's say. I feel like if you look for negativity, you're going to find it. So don't look for it. You know, focus on what you're there to do, the job you're there to do. And I found that if I wasn't focused on it, everybody else forgot about it pretty quickly as well, because I showed them that I was capable, I was smart, I could get the job done. And after all, that's what we were all there to do anyhow. So I found that to be a really good strategy to just kind of get past any of those kind of things. I remember I joined a board a few years back of a company, a French auto parts company, and at the time, all the other board members were men. And one of the directors commented to me, oh, you know, this is going to be difficult for you, this board full of men, you're the only woman. And I remember thinking, this isn't going to be hard for me. This is the story of my life. This is going to be hard for you. You know, you're the one who's all of a sudden got something new and somebody new to deal with. As an aside, he's no longer on the board, but I still am. So you young ladies are really lucky because your homes are here in southwestern Ontario, right in the heart of this incredible ecosystem that has developed around technology and exciting areas such as artificial intelligence and machine learning. You know, from institutions like where you're sitting right here, the Perimeter Institute, focused on, you know, fundamental thinking, to a fantastic network of universities, of colleges, incubators, accelerators. You know, you are sitting in the second largest technology cluster in North America, next to Silicon Valley. That's pretty exciting. We also boast the second highest density of technology and science startup companies in the world, right here in this region between Waterloo and Toronto. That's pretty exciting. That means there's a lot of companies that are getting going here, a lot of new ideas, leading edge technology, and they're all looking for graduates in the tech and science fields. In my opinion, there's actually never been a time frame where the technological evolution, thanks to these new technologies, will transform so many industries and so many companies. You know, the manufacturing industry is a really great example of that. With the advent of, advanced robotics, collaborative robotics, other advanced technologies, we're rapidly transforming manufacturing into a technology industry, which is true of a lot of other industries out there as well. We have fewer and fewer people on our shop floor actually running equipment, and way more doing more interesting, exciting things like programmers, designers, tool developers, robotics technicians, logistics coordinators, and the list just keeps going on. All kinds of really interesting, high-paying jobs. And in addition, we are doing, as I mentioned at the outset, some really important things in terms of solving some of our world's biggest issues, reducing and eliminating emissions to improve our atmosphere, developing technologies around clean water or clean power for our communities. And, the fact is, in today's rapidly evolving technology world, the demand for unskilled jobs, I think, is just going to continue to diminish. And I think that is why it makes it even more critical for all of us to acquire skills to be part of this exciting new world that is coming up in front of us. You've made the right first step by coming here today and learning a little bit about all the different exciting areas of STEM that you may want to study. So I hope you all have a fantastic morning, that you learn something new. Ultimately, of course, I hope that you decide to pursue an education in science, technology, engineering, and math, and that you convince other young women that you know to do the same. So with that, I think we have just a few minutes for questions. Yeah? So happy to take any of your questions. Who wants to be first? It's always hard to be the first. See that? I answered all their questions. There's nothing left. Yeah, we have one here. You're always the farthest from the mic,
Hi, my name's Sophie. I'm from Assumption College in Brantford. I just wanted to ask you a little bit more about your journey from where you started up to where you got in Linamar, and some of the obstacles that you faced and how you overcame those.
Sure. So when I started at Linamar, I started on the shop floor running a machine to just really understand the basics of our business and metal removal and what we did and how we did it. So that was great. And then I worked my way around to really every different area of the business. So engineering, quality control, accounting, material control, every aspect of the business, estimating, etc. And I found that really invaluable to me, certainly ultimately when I took over my first plant, to run my first plant, because I'd seen the business from all those different perspectives, and I think that really helped me kind of understand how it all worked together and how to make realistic expectations of people. So I would really encourage that as when you get through your education into the working world, to try and get a variety of experiences. Don't be worried about taking sort of a lateral move. It's not necessarily a promotion, but it's over here into something new. You may find different areas that you like even more than the area that you started out, and it'll just make you a more well-rounded executive. It was a great experience and I learned a lot, but it was tough because every time I switched jobs, I'd have a whole new group of people who I'd have to convince that I was capable and on the team and I'm going to work hard and smart and can do the work. So it was a little bit tough, sort of emotionally, I guess, from that perspective. But I think also it just made me stronger and tougher, to go through that, time and again. Just made me stronger. And now I've got this incredible network of people all through the company that I've worked with in all kinds of different plants and who have landed in all kinds of different places, who are people I can go to for advice and who are my advocates in the company as well.
Awesome. Thank you so much.
Thank you. Any other questions? Okay, well, look, it's great to be here. I'm really excited about hearing from the rest of the speakers and the panel. And again, I hope you guys have a fantastic day. Thank you.
Thank you, Linda. Our next speaker is Katie Mack. She's a theoretical astrophysicist who studies a range of questions in cosmology, the study of the universe from beginning to end. She is assistant professor of physics at North Carolina State University, where she's also a member of the leadership in Public Science Cluster, and is currently visiting Perimeter Institute as a Simons Eminata Fellow. Throughout her career, Katie has studied dark matter, the early universe, galaxy formation, black holes, cosmic strings, and the ultimate fate of the cosmos. Alongside her academic research, she is an active science communicator, both in traditional publications and social media as Astro Katie. Her book, The End of Everything, Astrophysically Speaking, comes out in June. Please join me in welcoming Katie Mack.
All right, I have to set up my computer here real quick. Hope this works. Awesome. All right, well, it's great to be here. Thank you all for getting up so early in the morning and coming out here to hear us talk about careers in science. So I'm going to talk a little bit about how I got into theoretical physics, how I started thinking about astrophysics and the cosmos, and the connections between studying the cosmos and studying sort of the fundamental nature of physics. So there are all these really deep connections between what we see out there in the universe and the way that physics works on the smallest scales in the sort of deepest sense. So I'm an astrophysicist. I study things out there in the sky. This is a photo from Australia, where you can see the center of the galaxy, actually, in sort of somewhere in there. But this is not how I got into studying astronomy. I grew up here in Los Angeles, and that's the color of the sky in Los Angeles. You do not see the cosmos in Los Angeles. You see stars of a different type, but not that type. So the thing that got me into astronomy, into physics, was really just wanting to understand how everything works. So this is a photo of me when I was a little kid. That's me there, fixing some neighborhood kid's bike. I was the kind of person who would take apart the remote control, and I just wanted to understand how it all fit together. Like, what made things work? What are the sort of fundamental ideas behind things around me, everything I could find around me. And by the time I was in middle school, I was a very geeky little kid, doing my homework before school with my little calculator out. But this was all part of just really trying to understand things. And as I got older, I would start to read up on more and more advanced concepts. So I was really into Discover magazine and thinking about, like, what about higher dimensions of space? What about, how does mathematics fit together? How do you think about time and things like that? And then I started reading books like this, A Brief History of Time, and I really loved the sort of mind-bendy aspect of that, trying to wrap my head around things that were so far out of my experience. And then when I was in high school, I got a very unique opportunity, which was I was able to do some actual research at a physics facility in Japan. So this is the Super Kamiokande neutrino detector. And I got to go there and do very simple work, sort of taking measurements of radon in the cave. So this is a facility that's underneath a mountain in Japan. That's a picture of me at the control room. So the reason I was able to go is that my high school was connected to a university, Cal State Dominguez Hills, and so I was able to get in touch with the college professors and go and work at that experiment. Now, I was interested in, space and time and geometry and things like that. I had never done anything in experimental physics before, and the work that I did there was not particularly deep. I was kind of babysitting the neutrino detector and making sure nothing went wrong. But I was able to learn more about particle physics and start to see the connections between particle physics and the universe. Just to give you a little bit more idea of what it was like there. This is the entrance to the mine. So the mine the detector is underneath a mountain to shield from cosmic rays. So you drive into the mountain from the bottom, and you go in a kilometer into this tunnel, and then you sit in this control room. And I was working the night shift, so I would get there at midnight and sit there all night looking at these displays and watching neutrinos come into the detector and light up the little display and try and make sure nothing went wrong. And every once in a while, because it was an active mine, every once in a while somebody would run in and wearing a hard hat and yell something in Japanese, and then the building would start to shake because they were blasting, because they were getting more zinc out of the mine. It was an exciting time. But one thing I learned about neutrinos was that neutrinos are these little particles that come from the sun, and they can travel through. They could travel through the whole Earth and not care. They could travel through a light year of lead and only have a 5% chance of interacting with anything. But we can detect them in machines like this. And if we do that, we can actually make an image of the sun in neutrinos. This is an image of the sun in neutrinos. Now, half of the neutrinos in this image half of them were seen at night, right? So some of them are coming right through the Earth, all the way through the planet, not even noticing. Some of them are coming through in the other direction. And you can build up an image of our sun because our sun is producing those neutrinos. And that was one of the first ways that I saw the connections between space and the subatomic world. What's happening out there in the universe and what's happening on scales so small that we can barely even detect them, even if we build a 40-meter tall, 40-meter wide cylindrical detector with all of these tubes and water and everything, and trying to detect these tiny things. So then after high school, I got into college, and I started to really study the cosmos itself, and I started to do research on the epoch when the first stars and galaxies were formed in the universe, and started to learn about how galaxies come about and what it is that governs the evolution of the cosmos. When we look at images like this, so this is an image of a cluster of galaxies, we're looking at galaxies that are in the very distant past. Some of the little splotches on this picture, sort of in the background, are galaxies that are so distant that when we see them, we're seeing light that left those galaxies billions and billions of years ago. And so as we look out into the cosmos, we're really looking back in time. Here's just an illustration of that. If you're looking at a deep field image from the Hubble Space Telescope, you're looking back to a time when the universe was maybe only 500 million years old. And as you look farther and farther back, you can start to see light that's coming from some of the very first stars and galaxies in the universe. And one of the things that I was interested in college was I was working on the question of, what do we see if we can see those first stars and galaxies? What happens in the time when the first stars and galaxies are forming? How does that work? And I started to get interested in other questions about how do even those things come about? Like, what happens if you look so far away, that you're looking so far back that it's the time before stars and galaxies are forming? What about when you look so far back that you're seeing closer and closer to the Big Bang itself? Because we know that the universe started from this very dense, hot state called the Big Bang, the hot Big Bang. And so if the universe was hot and dense everywhere at very early times, then we can look so far back, so far away, that we're looking back in time, and we're looking to a part of the universe that, from our perspective, the light from that part of the universe has left it so long ago that it's still on fire. It's still in that hot, dense state. And so we can actually see the Big Bang itself. We can look out, and we can see light from parts of the universe that are still in that primordial fireball state. And when we do, we can map out the radiation from that time, and it's called the cosmic microwave background. This is a map of the afterglow of the Big Bang. This is a sort of projection of the whole sky. And in this image, what you see is tiny, tiny fluctuations in temperature of that early fireball state of the cosmos, of the time when the whole cosmos was in this sort of churning, roiling, fiery plasma. And we can look very carefully at these little fluctuations, these tiny little fluctuations in temperature in that early time fireball state, and we can see that there's little bits of the universe that were a little bit more dense and little bits of the universe that were a little bit less dense. And we can take that information, give it to a computer, and say, okay, let's say that we have matter, and we make a little bit of it more dense, a little bit of it less dense, and then we turn on gravity and see what happens. And when you do that, the parts that are a little bit more dense come together and create these clusters and these filaments. And this is a computer simulation of what happens when you do that. What happens when you take the information from that very early state of the universe, put it into a computer, and just add gravity. And what we see is what's called a cosmic web, where on these kinds of scales, this would be like a cluster of galaxies. There'd be galaxies sprinkled along here, and then giant voids. And then we go out and look into the cosmos, and we map out where the galaxies are. We see the very same thing. We see these clusters of galaxies and these filaments and these giant voids. And what that shows us is that taking that information from the very early universe, plugging it into a computer, and adding the physics that we understand of how gravity works and how matter works, we actually can get something that we see out in the sky. So we're really learning how to put together these ideas, how to put together the physics of gravity, our understanding of the very early universe, and how that's evolved over time to give this very beautiful, very complete picture of how we came to be, how everything we see in the sky came to be. And one of the things that we've learned from that is that everything, all of this, is underlined by a new kind of matter that we've never been able to detect, even in the largest particle detectors under the mountains, which is called dark matter. So when I showed this beautiful simulation, what I didn't tell you is that every little particle in this simulation is a particle that only does gravity. It only has gravity, has mass, but it doesn't do any of the other forces of nature. It's a new kind of matter that you put into these simulations that just purely gravitates, doesn't have electromagnetic interactions, doesn't have pressure. It's something called dark matter. And when you do these simulations with just dark matter, you do get the right distribution of matter, which tells us that there's got to be stuff out there that we can't see. There's got to be extra matter out there that's surrounding every galaxy in the universe that's really the basis of all the structure in the cosmos, but it's a new kind of matter that we can't see. We only see its gravitational effects. And what we think is that it's sort of surrounding galaxies and clusters of galaxies in these clumps. And we're now able to do something where we can actually map where that is. So this is an image of a couple of clusters of galaxies. And when we map out where the gravity is in these clusters of galaxies, we see that there's got to be all this invisible stuff that's sort of gathered around these clusters of galaxies. And this is dark matter. And dark matter is one of the most important things in the universe. It's most of the matter in the universe, something like 85%, such that if you do these simulations where you have only dark matter in your simulations, then you kind of sprinkle galaxies on top at the end, you get the right answer. So it's got to be the thing that's driving the evolution of the cosmos. And that's the thing that I'm really studying, like what is this weird, mysterious stuff? And there's another connection between that and sort of particle physics, which is that what we think is that this dark matter, this invisible stuff that's most of the matter in the universe that's collected around every galaxy in the universe, we think that this stuff is some new kind of particle that doesn't interact with electromagnetism, that would pass right through you if it hit you. That's probably passing right through you in this room right now, but that has gravity and has these weird properties. And it's something outside of our current understanding of particle physics. And so we have a number of different ways to look for dark matter. There are big experiments underground. There are attempts to find its effects in space. One of the things that I'm working on myself is trying to understand how it might have affected the first stars and galaxies. So going back to that picture of the very beginning of structure in the cosmos, what happened at the very beginning, how the first stars and galaxies formed, I'm interested in how dark matter might have affected those things. And I just want to show one more picture of one way that we're looking for dark matter, which is this. This is an instrument on the International Space Station called the Alpha Magnetic Spectrometer, AMS. This thing here, it's a sort of little box that's hanging off the edge of the International Space Station, and it's a cosmic ray detector, so it's detecting particles from space, and it's hoping to find some signature of dark matter particles doing self-annihilation. So there's this idea that maybe if a dark matter particle meets another dark matter particle in just the right way, they'll annihilate with each other and create some kind of particles that we can see. This is sort of our hope. This is something that would make it a lot easier to figure out what it is. And so this particle detector is looking for that. And so far, what this particle detector has found has been a lot of really interesting, weird results. So they've seen that there's way more antimatter in the universe than we expected, basically. A lot of really high-energy particles of antimatter, antiprotons and positrons, which are antimatter particles of electrons. And there's a chance that dark matter is the thing that's doing that, that's causing that imbalance, that there's that extra antimatter. But there's also a chance that it's something else. So when I've been working on dark matter and trying to understand what dark matter is, I've been very excited about the results from this experiment. But I've also been acknowledging that it's quite possible that what this experiment is seeing is other kinds of astrophysics. So there's a chance that all the positrons it's seeing are from pulsars, which are a kind of highly energetic spinning neutron star that creates jets of particles that shoot out from the poles and do these and create these sort of amazing pulses of radiation. And they also find a lot of antiprotons, and there's a chance that the antiprotons come from supernova remnants, from the explosions of massive stars, creating all these charged particles as the remnants of the debris from the star expands. And so I think it's fascinating how even, looking for the stuff that's the most of the matter in the universe, that's underlying all the structure in the universe, can tell us something maybe about the physics of the very smallest particles, maybe about supermassive stars exploding, maybe about these highly energetic spinning remnants of stars called neutron stars. There's so many things that we learn about the cosmos when we're trying to understand something about particle physics and vice versa. So this is something that I think is very exciting, and I just wanted to sort of emphasize those connections between what you learn when you're trying to look at the smallest things and what you learn when you're trying to look at the largest things, and how, just because you have an interest in one sort of area of science, you might learn about other areas. You might take some kind of meandering path and find something that's really, really fascinating that it seems to be a sort of polar opposite, but actually is all part of the same thing. So I think I'll stop there, and I will take any questions. Thank you.
But just as someone's coming up, we actually had some questions from our online audience from Gloucester High School in Ottawa. We had some questions from them, so maybe we'll just start with one of theirs. They had a question about black holes. If black holes trap all light and can't be seen, how do we know they're there?
Right, so one of the ways that we know black holes are there is sort of similar to one of the ways that we know that dark matter is there, is that they have strong effects on the stuff around them that does emit light. So with dark matter, we know it's there because it affects the way that stars and galaxies move around. With black holes, the ones that we know about, there are a couple of ways we know about them, but one of the ways we know about black holes is if a black hole has matter falling into it and it makes a sort of whirlpool as the matter is falling in, and because of this extremely strong gravity, it sort of the matter sort of crashing together, and it's like a really strong whirlpool. There's all this friction, and so that makes the matter heat up and start glowing. And so a lot of times we see black holes because we see a strong X-ray source. So there's stuff that's so hot that it's glowing in X-rays. So like when something's really hot, we think of it glowing red or glowing blue if it's really, really hot. If it's glowing extremely hot, it glows in X-rays. And so we see this X-ray light coming from very distant objects. And that's one of the ways, that's the first way that we've found black holes in the universe. And there are a couple other ways we see them now. We can see them with gravitational waves when black holes crash into each other. We can see things moving around black holes in very close orbits in the center of the galaxy. We see our supermassive black hole that way. But mostly it's because when stuff falls into a black hole, it doesn't fall straight in. It swirls around and heats up, and we see that light. Hi.
When you have a question, when you have a question about astrophysics, how do you research the question? What kind of resources do you use?
Yeah, so there are a lot of, it depends on what kind of question it is. So, I mean, for me, so, you know, because I've gone through undergraduate and PhD in astrophysics, like I have a lot of resources in terms of textbooks and in terms of notes from classes and stuff like that. But generally, the first thing I do is I look at papers that have been published by other researchers, and I see if people have looked at that question, or just, you know, a lot of things, there's a lot of information just out there on the internet. So if I'm moving into a new field, like let's say I wanted to know something about red giant stars, you know, and that's not my specialty. I study cosmology and other things, but if I wanted to know something about red giants, I mean, first I'd go to like, Wikipedia, and then I'd go to some university pages that have pages by researchers who are specifically looking at that, and then I'd look at the literature in terms of published papers. But if there's a question, a sort of research question, then the best thing that I can do is talk to people who work on that question. So I have colleagues around the world who I've gotten in touch with through conferences and being, you know, at the same universities and stuff. And so I can always figure out like, oh, you know, I know this person works on massive stars. Maybe they have somebody I can talk to direct me to the best resource on that. So one of the things that I think is not always understood about theoretical physics is that it's really, really collaborative. Like we almost never work alone. You know, just wandering around the halls here, you're constantly running into groups of people, you know, standing next to blackboards, writing equations, talking to each other. Almost nobody is sort of isolated. And so it's always about, you know, we each have our little areas that we work on, but then we talk to each other and we share ideas and we try and come up with new creative ways to answer questions.
I have another question. What's the meaning of voids you talked about?
Sorry?
The voids?
Voids? Giant voids. So I was talking about these, you know, big sort of empty spaces between galaxies. So there are some parts of the universe where there are fewer galaxies than other parts, and we just call those voids. But it's not. I mean, you can see them as well in you know, developing in this simulation where places where there's very little matter to begin with, that matter flows toward the more high-density places, and so those spaces sort of empty out. So it's not completely empty, no.
Okay, thank you.
Sure.
Hi,
Hi.
my name's Emily. You were talking about dark matter a lot.
Yes.
Is that similar to dark energy?
Good question. Dark matter and dark energy. So they have very little in common in the sense of they act in very different ways. They're both called dark because we don't understand them and we don't know what they are, basically. And they're invisible. Both of them are invisible. But dark matter is a kind of matter, so it's something that has gravity that pulls other matter toward it. Dark energy is something that kind of does the opposite. It stretches space out. So when Einstein talked about gravity, he talked about the shape of space. So something that's massive is kind of pulling space toward it and making like a dent in space or a sort of concentration of space. And dark energy is something that stretches space out. So it makes our universe expand faster and faster. So in 1998, astronomers discovered that the universe is expanding faster than it used to be, which is weird. We thought that it would be slowing down in its expansion since the Big Bang, and it turns out, as of 5 billion years ago, it's speeding up. And there's nothing in sort of our standard understanding of physics that would allow that to happen. So we had to come up with something called dark energy, which would be something that would make space expand faster. So it just kind of stretches space. And we don't know what it is. We think it's probably something called a cosmological constant, which is kind of just a property of space that makes it want to expand more. But we call it dark energy because we're not really sure, and we can't see it.
One more. What sort of obstacles have you faced, like, through your career path?
Obstacles. I mean, So there are a couple of things that are hard about academia and physics in particular. I mean, one of them is just that it's a lot of hard work. So I didn't get very much sleep in college, and you know, it's hard to work when you're not sleeping. And also, as an academic, you tend to move around a lot. It's hard to be kind of, you know, grounded in one place or another, and so you end up, like for me, I've moved to different countries at kind of every stage in my career, and so I've had to sort of make new friends and kind of do a lot of sort of rebuilding my life up and stuff like that. So to me, like a lot of that kind of personal side of things has been difficult. Now, not everybody does that. A lot of people stay in the same country their whole career, or sometimes some people are even lucky enough to stay in the same kind of region. But for a lot of people, academia involves a lot of kind of moving and being flexible about your lifestyle. And so that's been difficult, but also, you know, very exciting in a lot of ways. So it varies. But mostly it's just, you know, it's a lot of hard work, and for me, it's worth it because I really enjoy the work, but it doesn't mean it's not hard. Like, I think one misconception that people have is that if you're somebody who should be a physicist, it should just come easy to you, and so if it doesn't come easy to you, then you shouldn't be a physicist, and that's ridiculous. Like, it's hard, you know, and it's okay if it's hard. It's okay if, like, when you start a new field, you're struggling, because that's how it goes, you know. Like, you start something new, you struggle, and then you get better at it as you practice, and so that's something that I always try and tell people, like, don't be afraid of having to work hard. That doesn't mean you're not good or not a natural or whatever.
Thank you.
Thanks.
We'll take one more question. For those of you in the line, Katie is going to be here during the speed mentoring session, so hopefully you can ask her one-on-one. Yeah.
My name is Alina, and I was wondering, if you reach the edge of the universe, what would, like, past the edge of the universe look like?
Right, so as far as we know, there's no edge of the universe. So in this kind of image, what we're showing is the edge of how far we can see. And the reason that there's an edge to how far we can see is because if we look too far away, we're looking so far away that the light from that point has taken the whole age of the universe to get to us. And so you can imagine, there's something beyond that distance where the light would take more than the age of the universe to get to you. So the universe is 13.8 billion years old. So imagine there's something so far away that the light would take 15 billion years to cover that distance. It hasn't got here yet, right? Like, so we can't see the light from that distance because it would take longer than the age of the universe to get here. So there's a clear edge to our observable universe, but in terms of the actual, like, cosmos, we don't see any evidence for an edge. We don't see any evidence for a center or an edge. There's just, like, there's where we are, and we have some view from here, and that view from here has a sort of hard wall where we can't see beyond that. But as far as we can tell, the universe is basically the same everywhere. And you know, if you look on the large enough scales, like, you can't see any indication that it's more, you know, that it's going toward something different in one direction or another. So there doesn't seem to be an edge. There doesn't seem to be a center. There's just sort of our perspective and how that changes because of how long it takes light to travel. Does that help? Sorry.
Thank you.
Okay.
Thank you so much, Katie.
Thank you.
Okay, we're now ready to start our panel discussion. I would like to invite our panelists to come up to the stage. Just as they're coming up, this is a nice moment just to stretch a little bit as I'm talking. So if you're feeling a little cramped in your seat, you want to adjust yourself, stand up, stretch your arms up. Our panelists are going to be sharing to where they got to today, and they're going to be telling us about their education and the choices they made along the way. We're fortunate to have 4 panelists representing a range of specialties and work experience. You can find them listed in your program. And What I will do to start off the session is I'll be inviting each of the panelists to tell us a little bit about themselves and their career path. I'll be moderating the discussion, but the floor is always open for questions. So even as they're getting started, telling us about themselves, feel free to form a line at the microphone so we can fit in as many questions as we can and not be kind of caught at the end with lots of questions at the end. So feel free to get started. Because indeed, questions from you are going to be far more interesting than questions from me. So, Vanessa, let's get started with you. Could you take a few moments to introduce yourself and tell the women here a little bit about your story?
For sure. So thank you so much to the Perimeter Institute for having me. My name is Vanessa Pony, and I am an engineer. So kind of growing up, I didn't really know much about engineering, and I was just kind of in the sciences and maths because my mom recommended it, and she was like, it'll help keep your options open if you just kind of stay in those things. And I kind of stumbled into engineering. It was 2 individual conversations with one friend from swimming lessons who was 1 year older than me and one friend's dad who happened to work at Bombardier. So these 2 experiences is what led me to apply for engineering in grade 12. And then I went to McMaster with a dual degree in engineering and business. So I'm a materials engineer, and then I also have a management dual major. And throughout university, you can do these things called co-ops where you actually get paid over the summer to work in industry. So I had the opportunity to work at Bombardier Aerospace, Pepsi, both foods and beverages manufacturing. I got to go to France for 8 months where I did an exchange program doing research and studying at the Grenoble Institute of Technology, and also working in Vancouver for a little bit. So really kind of exploring my options. And I ended up working at Spin Master in Toronto. So it's a toy manufacturing company. We created Paw Patrol, which is pretty exciting. And we're actually Canadian founded, and we're mostly because of Paw Patrol. We are now like number 4 in the industry. So it's been really exciting to work there as a product development engineer, where I work on like remote controlled cars and games. So very fun job. Throughout my undergrad, I also, at some point, created a national not-for-profit organization called Engiqueers Canada. So I'm a queer woman of color, and I've been really passionate about intersectional feminism and, just advocating for a broader spectrum of diversity than just saying we need women in various spaces. And I was able to kind of just create this organization at McMaster, and it slowly grew to 32 universities over 9 provinces over the years. And it's just this need for having broader discussions around diversity and talking about queer issues and having queer communities within STEM was just really, really needed. And it was really exciting to kind of go on that journey. And just one thing I wanted to kind of note is that, I've been in these audiences of these kinds of things at different stages of my life. And sometimes, a lot of you are, between the ages of like 14 to 18, you're going through all sorts of stuff right now. And I don't want you in any way to feel like intimidated, like, oh, these are these people who've done all these things, and am I ever going to get there? And so I just wanted to share a little bit about my background, because undoubtedly a lot of people in the audience have shared things like this with me. So, forgive me for the heaviness, but I just want you to know that throughout my journey, like I have overcome, my father has been homeless and had mental illness. I've been suicidal at different points in my life. I overcame child sexual abuse from my stepfather. There's been so many things that have happened. My mom immigrated from Sri Lanka, and we didn't have a lot of money growing up. So I don't want you to think that if you have been through these different hardships in life that, you can't have a path to success. You can't overcome these things if you're struggling in something right now. And so I want you to know that like people like us have been through these things too, and that you are not alone, and there are other resources for you. So I just always want to make sure I say those kinds of things when I'm on the stage. So thank you for your time, and I'll pass it on.
Thank you very much. Thank you very much for the invitation to be part of this panel. So I'm Hinda Badri. I'm a chemistry professor at Wilfrid Laurier University, and I have another list of titles that you have in the program. I'll just add one thing that I didn't put in my biography, which that when I was growing up in the United Arab Emirates, I went to an all-girls school throughout the K-12 education and also in university. So I think when I entered science motivated and empowered because my teachers were women from age 6 all to 18, and also the school staff and everything, and everybody who worked in all-girls schools. So I welcome your questions to see what you have in mind to ask of me. So.
My name is Jessylyn T. You can see my little bio in the pamphlet there. I am a pilot. That's why I'm wearing this uniform today. I'm a pilot for Sunwing Airlines. So it started for me when I was 8 years old. I was the kind of kid that knew exactly from that day on what I wanted to be, and I chased after that. So it's a little interesting to be here speaking at a STEM event because I was never super excited about science. It was just something that I had to do to get to my final goal, and I ended up loving it. So when I was 8 years old, I went on this little intro flight up in a small 4-seater aircraft, and I loved it. And from that day on, my parents kind of jumped on that dream with me, and I went to every local air show. I took every opportunity I could to go up in a plane. And then when it came to choosing my post-secondary, I chose the University of Waterloo. I chose that program because I still knew I wanted to do a degree, so I did a Bachelor of Environmental Science alongside my flight training. From there, it took 3 years for me to do that. I then got hired by Sunwing Airlines into a cadet program. So basically what that means is the old way of getting into an aviation job, you used to have to go up north or go instruct and build thousands and thousands of hours until you could see yourself at an airline. But because of the demand right now for aviation professionals, whether that be pilots, maintenance engineers, ATC, anything, they're fast-tracking that process. So I got hired at Sunwing with only 250 hours, which is not very much, right? Going from flying a 4-seater aircraft to an aircraft with 189 passengers behind me. So it was a big jump. It was very challenging. But it took 6 months of really intense training, and I'm there now. I've been there for 2.5 years. And since then, I've gotten to take more of a role in mentorship, in coming back to the University of Waterloo and kind of working with students in this new transition phase of going into these, like, you feel like you're drinking out of a fire hose kind of experiences. And then also going back to the Waterloo Wellington Flight Center, which is here at your local airport, and teaching a course there as well. So I've been able to kind of come back. My whole motto for coming back is to equip, empower, and encourage young women like you today and men as well. So yeah, that's a bit of my story. I'm excited to answer some of your questions. Again, being a pilot might not be seen as the first thing you think of when you think of STEM, but it is within that realm, and I'm excited to speak to you guys about that.
Good morning, ladies and allies. My name is Sarah Sun. I'm Chief Data Strategist of a small company called Goldspot Discoveries. We are a company that brings together artificial intelligence into the mining industry. When I was your age, I loved math. I did everything that I could do in mathematics, but I was told, even by my parents, that you couldn't get a job in math. And so I did everything, and I thought I loved everything growing up. And so on the complete opposite end of the spectrum, I wanted to be everything from a doctor, a lawyer. I went through a marine biologist phase. I worked during my internships, like I worked in a biological lab, working with gene expression in eye cells. I have worked IT help desk. I did absolutely everything, and it wasn't until my 4th year of university that I ended up declaring my majors. So I ended up majoring in mathematical finance and statistics, and it's a miracle that I graduated on time because I loved everything. I took to biology, to chemistry, I took physics, I took everything I could get my hands on and realized, and only by exposure to lots and lots of different things did I actually realize that turns out I don't like everything in the world. So, but only by experiencing it and putting myself in those situations did I realize that, like, I love the idea of using mathematics to solve real business challenges. So when I came out of school, I basically became a data scientist. I got to use data, I got to understand and use my math degree to understand the challenges in the financial world. I did that for a few years. And then for some reason, I woke up one day and I was like, I'm really bored in finance. What's going on in the mining industry right now? And I moved into mining where I'm still doing data science, but I do a little bit more of the strategy side of things as well. So I'm less on the building models, working with the data, more working with the clients now, understanding, walking into organizations and teaching them and partnering with them to take advantage of the explosion of interest in artificial intelligence.
Okay, so I'll invite everyone to come up to the mic with your questions. But maybe just to kick things off, what is the piece of advice that you wish you'd known in high school when you were making your education choices? If you could go back.
My biggest piece of advice would be that you do not need to know everything about your future. Like, some people do, which is amazing, and I'm sure there's lots of people in the audience who already have a really clear vision, but if you are not one of those people, like, things will change over time. Like, I entered loving chemistry, and that was why I went into engineering, and now I literally never use chemistry. Like, I'm now more of like a problem solver. The business side of my degree has taken over a lot, but then I'm still like on a sustainable materials initiative where we're trying to like implement bioplastics and biodegradable plastics into our products. So like, your career will evolve and flow, so just kind of, you know, letting yourself go with the flow is my biggest piece of advice.
Sorry, I can just add a piece off of that.
Yeah.
Going off of the enjoying to go with the flow sort of thing, I just want to encourage all of you here today to enjoy the process. Take your time to kind of let this day sink in. Don't feel rushed to make your decision after this or to feel super inspired, but enjoy the process of trying to figure that out. It does take time for some people. Again, like, my story is a bit different because I knew what I wanted to do, but that also set me on a very fast track to get there. And I think looking back on it, there's some times when I could have just taken a couple deep breaths, maybe enjoyed it a little bit more rather than stressed about it. But I'm thankful to be where I am today, but I'm trying to take it a bit slower now. So yeah, enjoy this.
It was definitely make your own opportunities. Like, luck is, you'd be surprised how much luck can factor into someone's journey, but you can't wait for luck. But opportunities, sometimes you have to ask. Sometimes you have to go and say, I want an internship with you, or I want to be like you one day, or like, why can't I be part of this program? And quite honestly, I think you'd be surprised how many times you run into a situation where the organization or the person or whatever it is you're trying to do, they're just like, oh, we never thought about it before. Okay, let's make an opportunity. So don't be afraid to make those opportunities for yourself.
My name is Nuha. Oh, there, sorry. My question is for all of you, what would you say is your moment when you felt like, okay, I've made it, or like your most proud moment in your journey personally to yourself?
Well, I think earning a PhD in chemistry was a milestone that I'm very proud of. Because, you know, everybody goes through high school, everybody goes through the undergrad education. I think grad school is a very special experience because to go to grad school, you have to commit from 2 to 6, 7 years of your life to be specialized and to work with, you know, experts in their fields, and sometimes you have to relocate to another country and you have to build up your social life from scratch, away from family and friends you grew up with. So the whole experience together and to earn a PhD, an advanced degree in a very specialized area, for me that was the milestone and the highlight. Yeah.
For me, I was, is this on? Yeah, there we go. I was 22 when I got the job at Sunwing, and at that point I was the youngest female first officer on a Boeing 737 in Canada. So that, thank you. So to me, also coming straight out of university and finally having a job from what I studied for and getting paid instead of paying for it, that was kind of like a made it or milestone moment for me. But again, I said I was only 22. I didn't feel like I was finished yet, so I didn't want to look at it as I made it yet. I wanted to look at my next goal and see what I could work towards next. So I'm still trying to make it.
Yeah, I don't know. Very similar. I I never feel like I've made it. But I think I have learned that it's really important to take time and appreciate what you've done. I have moments in my life where I've looked at something and realized that like this has given me a goal, or I feel like I missed something, and so that's created my next goal for myself. So 2 moments for myself really stand out. One was in 2013. I also coach a group of students in Toronto Math Circles, but we decided to compete in a US competition for the first time in like 20, 30 years. And we won our division. And for me, that was like, I was like, oh my goodness, we have so much talent in Canada, and then we walk into this American competition where we're one of 3 Canadian teams and we just take it. And it was just incredible, right? It's like, yeah, super exciting. And then last year, I won an award for the Women's Executive Network. I was named one of the top 100 and in the science and tech. And it was funny because I think the year, I had turned 30 recently. And when I turned 31, I had that moment where I was like, I'm never going to make a top 30 under 30 list. And so it was weird. I know it's really weird, right? You look at this and you're like, but I have so much to offer. And so I went on this journey. I'm just like, I'm going to prove to you that I can do lots of things for you, and I'm going to continue doing so. So the journey never ends. And I think this idea of like self-improvement and this idea of what is your next goal and what is your next step, I think it's really important to understand for yourself, is there an experience, is there something you want to learn, is there something you want to achieve, and that never ends.
Hi, my name is Amanda from Victoria Park in Toronto. My question for everyone is, was there ever a time when you faced a challenge where you wanted to give up, and what did you do to overcome it, and how did you not give up in the end?
Yeah, big time. So I mean, when I was 16, I made the decision I wasn't going to go to university because it was too expensive. And I went on this journey of like just mentally preparing and accepting the fact that I was going to have, $30,000 of OSAP debt the day I graduated, and I just needed to just accept that when I was like 16 years old, and always applying for scholarships and not getting them for years and years and years and years, just like trying so hard and not getting them, but eventually getting them later in life. But for me, I think it was I kind of mentioned some of the things I've been through in life. There was this particular period where it was a perfect storm of like court case, my dad passed away, like all these things happened back to back to back, and I was just like, I'm done, no more, I can't. And for me, what I chose to do in that time, I actually did 6 years of university, so it was a 5 academic year program to have like that dual degree, plus I took a year off. And choosing to take that year off, I literally, when everyone's like, oh my God, what are you doing in Vancouver? I'm like, going to work, cooking dinner, exercising, repeat, the end, forever. So sometimes just for me, it was taking that time to recover and recuperate is what helped me keep going. Yeah.
I think what I found helpful going through challenging times was to put my mindset in a way that I can channel that negative energy into positive energy, and sports is excellent for that. You sweat it out, you sleep on it, and then when you think it over, you find that it's a phase that will go and pass on. It's not the end of the world, and then you have to. Read your CV. Just have a written document that you actually can go to remind yourself of how during the good times, this is what you were able to achieve, and this is something that is passing and it will go away. I also found helpful reading memoirs. Reading memoirs of people that you admire, whether they are alive or dead, doesn't matter. Reading books and reading, I like to read nonfiction because nonfiction I can relate to, whereas fiction is fiction. So basically, immersing yourself in activities that will make your mind center around what you have to offer and instead what is challenging for you to overcome. Yeah.
I'll give you a very specific example. So going through flight training, you do your private pilot license and then you do your commercial license. So to get those licenses, you do a written exam and you do an actual in-flight exam. So I was in university at the time and starting to figure out, okay, what jobs am I going to apply for after? And I wanted to apply for Jazz Aviation, which is one of the Air Canada partners, to go there. And I had gone to a presentation where they said, if you have a fail on your flight test or a partial, which means you didn't fail it, but you didn't pass it, you get another chance, we aren't going to look at your resume. So I have this like big presentation the week before I do my CPL, and I go into that commercial flight test and I partialed it. There was one item that I couldn't complete, and at the end of that I walked into the flight center in tears, just distraught, because I'm like, that's it, I'm not getting a job. So the chief flight instructor pulled me aside and he calmed me down, and then we took some time to think about, okay, what can I learn from this? How can I learn how to cope with this? Because this isn't the first failure I'm going to have in my next 40 years of flying. So in the end, I was very thankful that it happened then, so I could learn how to cope with it, learn how to get back into it. And the big thing that I took from that was like having resilience in the face of adversity through that. So I was happy it happened then because it has happened again since, but now I can look back and be like, okay, I took some time to regroup, I went up with my instructor again, I relearned that lesson, and then I was able to complete it successfully. So it wasn't the end of the world. I didn't not get a job because of it. I still got an interview with Jazz Aviation after that. So it's just nice to see that I was able to overcome that, and if that happens again, how I can react differently. Yeah.
For myself, I think I hear it echoed in all of our things. One of them is take care of yourself. It's especially when you're in a challenging situation, it's hard to realize that sometimes you need to take a step back, and you need to focus on your mental health, your physical health, and whatever it is for you that makes you feel happy and relaxed, pursue that and do that. Having a support system was really important, and that can be parents, friends, a family member, it can be your dog, your cat, but it's, reaching out to people and talking to them and just venting and just like getting those experiences out there, and then just having that support system, someone that you can message when you're having a bad day. That's actually really, really important in all of this. And all of those things give you the right mindset to like, now I'm ready. How do I tackle this challenge? And what can I learn from this challenge so I can avoid the situation next time it happens, or I can handle it with more grace the next time around?
Thank you for your great answers. Hi, I'm Jane from Mayfield Secondary. I was just wondering what your suggestions are for gaining that experience and finding those opportunities throughout high school and university, and what your suggestions are for finding a job and getting hired after university.
Networking. Number one important thing. Like, never underestimate just every single human being you ever meet and who they might know. And like literally, it's just, you never know the random conversation you will have. And then, I've gotten jobs because I connected with someone over chatting about their kids, and then they're like, so actually, what do you do? Tell me your interests. And that was the icebreaker. So you never know what's going to happen in that regard. And, for me, it was co-ops. Being able to physically go in industry and get paid to see what engineers did in these completely different industries and completely different fields just helped me understand, when I went to France, for example, is when I learned academia was not for me. I couldn't handle the pace. My task for a week would literally be find something interesting. And I was like, but other people find that really exciting. so for me, I need goals on the hour so I can deliver. So it's just really, finding what you like through just being in those places.
Yeah. When I was in high school, our books themselves that we used to study from have listed names of organizations, names of successful people and their experiences. And I found actually pursuing that to get to know more about them and do research about that was very enlightening. For example, I'll give you a real example. My very interest in environmental chemistry and environmental research stemmed from a class in the English book where they talked about the impacts of climate change back in 1993, that this is what will happen in 25 years' time. And they listed the name of an organization in the Netherlands with their address. So I just sent them a letter. I sent them a letter. I said, I've learned about you from my English class. I want to know more about what you do. And they emailed me. They sent me a letter back by mail. No emails at the time. With brochures. And so I got my interest developed in environmental issues in high school. So just look at your textbooks, not because your teachers want you to look into it. Just look at them as a curious being. What can I learn more beyond what the teacher wants me to learn? And pursue that. Yeah.
Yeah, I would say networking and mentorship for sure. This is a great start. You're going to get to do some networking. You're going to get to go to a mentoring speed session. And it's finding those mentors and using them as a resource as well to help you get connected, to help you figure out what are the different events that I can go and participate in and show that I'm curious about this industry or this job.
Absolutely. Take advantage of the people around you. You meet so many interesting people out there. And I find that, I'll do a lot of coffee chats, I'll meet a lot of people, and always extend sort of the same offer to the people who approach me. And very few people actually take me up on that. And so it's a very easy idea of like, if you are looking to get into an organization, et cetera, like you can see if I'm connected to specific individuals on LinkedIn, and I'd be happy to facilitate an introduction if I actually know this person or give you my take on that organization and that opportunity. And no one has ever taken me up on this offer, right? And so, but it's funny because it's again, create your own opportunities, ask, and don't be afraid. The worst thing that someone can do is just not answer you or say no. But you're not any worse off than you were before, right?
Thank you.
I'm just going to quickly interject to ask Hind a question because we have a group watching online from Burr Oak Secondary School in Markham, and they had submitted a student had submitted a question for you. What rewards and challenges are there in applying your research to problems you want to solve?
Rewards?
And challenges.
And challenges, yeah. So the rewarding aspect is when you actually have an idea on a paper, and then you go to the lab and you design the experiment that you think will give you the answer, and then you get that answer. Or you actually get a totally different answer that will set you on a different path that is more productive. And I'm experiencing this right now. Actually, there was a project that I started 7 years ago with a grad student, and we have been noticing a change in color when we mix certain chemicals together, and we never paid attention to it because we were so fixated in proving the hypothesis that we started with. We published on that, but then I said, maybe this color change actually means something. And when we started digging, that by itself set me on a path that I got, 5-6 papers out of just from studying the control experiment. We haven't yet done the experiment that we And it got me the Fulbright Canada chair position at the University of California, Irvine. So the rewards were beyond my expectations. The challenges is the perseverance. I mean, being a researcher, it keeps your mind active. It taps into that creativity you have. But it is a lot of hard work. It's a lot of dedication. It's a lot of sleepless nights. It's a lot of downtime. It's downtime that you have to go through from experiencing a failed experiment after a failed experiment. But once you hit the jackpot, it's called the jackpot, right? Once you hit that point, you forget all about it, as if you have not went through hardship, you have not went through sleepless nights, because it's just I think, what's the hormone? We have a biologist. What's the hormone that gives you that? Is it serotonin or endorphins? Yes. Thank you. You get that flush of endorphins that makes you forget all about it. Absolutely.
Awesome. Great. Thank you. We'll take another question.
Hi, I'm Lillian from Earl Haig Secondary in Toronto. And I was wondering, because you're all from different backgrounds and fields, what is the type of businesswoman persona you present to other people, like men and women alike? Like, do you tell them about your home life? Is that something that you present to others?
I love that question. That's a really cool one. Yeah, I think for me, that's why I've really gravitated towards Spin Master, is that the culture of this specific engineering team I'm a part of, we have a female director of engineering, a female VP of engineering, there's like queer people everywhere, and so I was joking with my sister, my kind of like vibe I'm going for is like a sustainable queer feminist vibe. And she's like, in my day, it was either trendy or tomboy. It's like definitely being really like being my individual self and like in the workplace and being, I just recently won a head cheerleader award at Spin Master for like being all enthusiastic all the time. So like definitely I find like for me, I value authenticity above like everything else, and I have no filter and I'm very open. So like that's something I just still emulate in the workplace for sure.
I think one of the hardest things going through the workplace is balancing what it means to be true and authentic to yourself and how do you portray that to the world. And I think you go through so many cycles of like, oh, do I have to be a certain person in certain situations or this, that, and you learn to navigate that. And I completely agree. It's such a buzzword, but it's so true. Like you gravitate towards authenticity in leadership and authenticity in the people around you. I don't like dealing with someone if I know that they're saying one thing to appease me, or they're acting one way, and then the next moment I see them be like a completely different person with someone else, and I'm like, I don't understand you.
You lose trust in someone.
You really do, right? It gives you a little bit of a weird feeling, and you're like, I don't know if I can trust anything, or I don't really want to do business with this kind of person, right? When it comes to like the personal side of things, it definitely depends on the person, the situation. I've worked in workplaces where it is your personal life and your social life and your work life is one and the same. All of my best friends still in Toronto, we all were analysts together when we all started at Capital One. And you know, I remember in that first year, like we went to Vegas and New York with a group of girlfriends that I met at work. So it eventually became really, really difficult actually to separate your work life with your social life, right? But I've also worked in workplaces where it has to be a much more professional kind of place. But there, the way to connect with people was still through these interactions. So I used to have a rule, if I go for a coffee chat, I'm like, I don't really want to hear about your work. I want to hear about you as a person. And then by connecting there, you actually are much more effective from a business perspective because you understand what drives them, you understand how they like to communicate, and you're able to bring that together in a way that's like true to yourself and your values.
The aviation industry is interesting because it's only 4% women worldwide, so it's still extremely male-dominated, and you could guess that most of the captains that I fly with are male. In the last 2.5 years, I've only flown with 2 females. So, and they're males that are, could be my dad. Let's just say that. There's that age gap. So it's a very interesting industry to go into as a young female. Both holding, being humble in that, because I got to that position a lot different route than they did, and that can be hard for them to understand sometimes. It took them maybe 10, 15 years to get to where I got in 2 years. So I come remembering that I need to be humble about that, but also being confident in my skill and in my education and the training that I've had, because I didn't have those 10 years of experience, it's easy to say like, oh, you don't have the experience to be here, or oh, you don't deserve to be here, that sort of thing. So being confident that I've been trained to the same standard as them, and I've passed multiple tests, and yeah, confident in the work that I can do there. The other interesting part is we're doing layovers with our colleagues. We're doing 14-hour days where I'm up in the flight deck with the captain for that entire time, just him or her and me, right? So you can't just talk about flying the entire time. It gets pretty boring. Or the weather, or politics, right? So you get to know each other, and maintaining that level of respect, but interest, I think is really important, because a captain once told me people are going to remember you for what you've done, but they're going to more so remember you for how you treated them. So I want to take that seriously, and then also recognize that one day when I become a captain, I want to take that interest in my first officer and make it that welcoming, warm atmosphere or flight deck. So those are the kind of things I hold in my everyday.
Yeah, so I run a research group. So I work with students at different levels, undergraduate, graduate students, and I sometimes host high school students. One of the first things I have to know about them is how, is their time management skills, the commitments on their time, their interests, why they're doing the research that they want to do, what they want to do long term. So I invest that time with them in order for me to make sure that whatever project I put them on, it's gonna tap onto their skills. And it also will give me cues on what skills they need to develop in order for them to be successful after they leave my lab. So I think the answer to your question is that it depends on the setting that you are in. If you are going to work with a supervisor, I think you prepare yourself to actually set the goals. Short term, long term, why do you want to work with that person? What is it that you have to offer that person? And what is it that you want to learn? And what is it that you will see yourself doing in the next, 2-3 years afterwards? Skills-wise, you don't have to think of a position, just skills-wise. What is it that you'd like to learn? What is it that you have to offer based on the skills you already have? So if you go with that mindset, then you'll see that you are telling a part of you that is not too personal, but it is about your ability to contribute, your ability to learn, your ability to manage different situations, and that's very important if you work with managers or supervisors.
Thank you.
You're welcome.
Hi, I'm Sanjita. I'm from Victoria Park College Institute, and my question to you is, what inspired you to accomplish whatever you have today, or what you have achieved till now? Like, what inspired or motivated you towards this position of your life?
Right. The question for me?
No,
for everybody. Yeah. Okay. So let's start with. No. Okay. Well, this is a philosophical question that I think about every single day because you need to reason to get out of bed, and we have the director of the Perimeter Institute who started the session saying that society faces a number of challenges. From a philosophical point of view, if you just look at the human race in general, we do have challenges that we created ourselves because of how we run societies, but that also presents a series of opportunities. So I'd like to be part of those opportunities. I do not want to be the problem maker. I want to be the solution maker. So that's the big picture. That's the big picture. I recognize that human race, human societies have issues that they're dealing with, they're struggling with. There are challenges environmentally, socially, politically, economically, wherever you look. Just look at the Sustainable Development Goals of the United Nations. They have 17 of them. Seriously. Pick one. Just pick one. If you pick one and make it your life to fix it, you have something to get out of bed every day for. Print it, or put it on your wall. I want to end hunger. I want to make sure every single human and animal on this planet drinks clean water. So just look at those, and you'll see that there is a lot that you have to offer the world. So think about what you have to offer, and then tap into what resources are available, but always look at the possibilities. There is I don't know, it's an old saying I've heard, I don't know from where, I can't reference that, but it says that, it's an old wisdom, it says that opportunities present themselves as challenges in disguise. So do not always scratch the surface. When something presents itself, don't be satisfied with what you see. There's always something beneath. And usually what's beneath is the opportunity. And always remember, the diamonds and the golds are hidden in rocks that we call cheap, but they're not. You see what I mean? So information goes that way too.
Is there anything that anybody else would like to add? Or? Thank you.
Thank you.
Hello, my name is Lana, and my question is, because having a career in STEM is very demanding, how do you balance between personal life, social life, and the work that you do every day?
Right. Is that again for me?
For anybody.
Okay. Let somebody else take it.
I definitely find even in university, just balancing time and time management has always been challenging. And for me, I've always been the kind of person to put a lot on my plate. In final year of university, I was running EngineCourse Canada, so I was hopping all over the country all the time. I was overloading 7 engineering courses per term. I was in a musical, so 20 hours of practice a week. So it was just all this craziness. And as some people have alluded to, sometimes sleep is one of the things you sacrifice, but I don't recommend that where at all possible. But you just you decide what's important to you. At the end of the day, everything you're doing is a choice. You're choosing this career, you're choosing the friends, you're choosing the sports, whatever it is. And so you whenever you're feeling overwhelmed, you got to remind yourself that these are all things I want to be investing my time in. And, and sometimes I just want to be hanging out watching Netflix for 5 hours, and that's the choice I want in that time. So you kind of just figure out on a day-to-day basis, like, what do I have the energy for? When do I need that downtime and alone time versus when do I need like 5 events in a week because I'm going to be bored otherwise. So it's just about adapting and figuring out what works for you, and it's a journey. Like, you go through phases. Sometimes you're like, maybe I didn't need 3 events in one single night. Like, maybe I can do 2. Like, so you're gonna grow and change in different points in your life.
The schedule as a pilot can sometimes be looked at as, oh, like, aren't you always away and always flying? And again, that comes into question when you're a woman and you want to have a family and that sort of thing. So that's something that, like, I early on had to consider and had to think about, how am I going to balance that with some of the other pieces I want to have in my life, like sports and community and that sort of thing. So one thing I can clear up is that the schedule is pretty flexible, and it's really diverse in the sense of we bid for our schedule. So it's all based on seniority. And there's from trips that you can be away for 5 or 6 or 7 days to trips where you can be there and back to Cuba in a day, and you're home for breakfast, you're home for dinner kind of thing. Again, it's not the 9 to 5 either, so you could choose to work on weekends, or you could choose to do Tuesday, Wednesday, Thursday sort of thing. So there's a lot of flexibility, there's a lot of options. And then I have 11 guaranteed days off a month, so I know that I'm gonna have some time off. In that, that's when I choose to prioritize, okay, I'm doing some professional development stuff, I'm still taking courses, I'm still learning, so maybe I'll set 2 or 3 of those guaranteed days off for that. And then 2 or 3 of my guaranteed days off for coming to Waterloo to see my community, or going home to see my family, that sort of thing. So it's really what you choose to prioritize. And for me, I'm a planner, so I like to say, okay, I have these days off, I'm going to be sitting in a cafe working on this mentorship program, or this is when I have time to give to this community. So yeah, hopefully that clears up the idea of the pilot schedule being you're always flying, because you're not.
I had to learn to say no a lot and not feel bad about saying no, because there's only so many hours in a day, right, to do things. I also had a great support system always. Like my husband is the homemaker. It's fantastic because he knows I do a lot of traveling. I'm not home. I'm not able to clean the house from top to bottom, etc. So he more than happily takes on all of that. He does more of the cooking than I do, and it was a weird kind of role reversal that his family had to kind of come to terms with, and we still get comments about it quite often, actually, about how like unusual that is, or like, don't you think that's a little odd? Or like, Sarah's traveling again? Why? Is this really necessary? Those kind of, we've had a lot of those moments in my time. And then the other thing is, I think it was important for me once in a while to take a look at everything that I was doing and to really look at what was actually bringing value to me. What did I actually enjoy doing, or what did I feel like I was doing out of obligation? And if I was doing it out of obligation, then maybe I should have a really hard look as to maybe that's a great activity for me to just say no, even though I'm really supportive of what it was at the time.
Thank you. I think we'll have time for one more question. Sorry, guys. I know there's a long line. But there will be the chance to, the panelists have told me they'll be able to linger a little bit at the end. So hopefully you can grab them in the speed mentoring session. Sorry about that.
Hi, I'm Sveta. I'm from Coffer Park Secondary School in Mississauga. And my question is, what is the one thing you wish you had known in high school that you know now? Please don't give any like cheesy answers. We want actual truth.
The real deal. This is kind of maybe a weird thing to say, but I wish I had known that your brain does not finish developing until you're 25 years old, which is such a random thing to say, but I just remember so many different times in my life where I was like, I have it all figured out. This is everything. This is how knowledge works. Like, I've got it down pat. And then when I think now at 25, how I used to think at various stages of my life, I'm like, holy crap. Like, I just had such a different perspective. So just knowing that when you feel like, I'm not by any means saying like don't trust yourself and don't like follow your instincts, but like leverage people in your life to get advice, and don't be intimidated if you keep getting advice that's kind of different than what you wanted to do, and sometimes accepting that like people around you who know you really well might be able to see things from a different perspective, because that's, I know, helped me a lot of things that I thought made sense, and having like best friends be like, like your boyfriend's dumb, like, and I'm like, what? No, he's great. like that kind of stuff, like, and that applies to like career and like all sorts of things. So like to just know like that you will evolve a lot in just the way you view the world.
In high school, I was the captain of a number of teams. I was on the basketball team, I was in gymnastics, I was in volleyball, I was in handball, and and managing studies and sports. So I learned healthy competition, I learned about fair play, and I thought this is how the world runs. And if anything surprised me after high school is that healthy competitions and fair play does not exist. And so it's a myth. It's actually a myth out there that there is a level playing field in the workforce. And actually when the questions that you come up with to ask us about what challenges you have faced, well, if it was healthy competition, if it was a level playing field, if it was fair play, then we wouldn't have the challenges, right? Everybody will know the areas they have the strength in, they know they're entering the play court, and they are going to shake the hands of the opposite team and leave happy, right? Life doesn't work this way. I hope that in high school they taught us that. They didn't. And this is, I think, what the School of Life have taught me. Yeah.
I think one tough thing for me personally growing up was this idea that you can outgrow people in your life. I had this conversation actually with a girlfriend about a week ago, and we shared some experiences where as you grow and you develop and your experiences changes, you want to surround yourselves with different types of people. And I had I clung on to some negative influences in my life growing up when I should have walked away. And it was because, you know, I think you have this idea like these are my best friends now and these will continue to be my best friends as I grow up, and you don't necessarily see when they're holding you back, or your life just goes, you just go in a completely different direction. You don't get the same internships, you don't go to the same universities, you don't have the same life experiences, and that changes you. And it's okay that your friends change at the same time. I'm not saying you need to like burn a bridge and have a huge argument, but having this idea that your friends will evolve and change, and it's natural for that to happen, and don't cling to, it sounds a little cliche, maybe negative energy or anyone who's actually holding you back in a certain dimension. Trust your instincts when it comes to that kind of thing. I wish I'd learned that a lot when I was a lot younger.
I think this is a simple answer, but obviously something I didn't understand back in high school. I was very shy in the sense of being curious about what I didn't know. So I didn't want to show this like weakness of like, oh, I don't know that much about aviation, but I really want to go into it. So I wouldn't ask questions. And I think that maybe did hinder me a little bit or make me more shy and lack of confidence in that sense. But then I went into this ground school at Sunwing, totally out of my comfort zone, totally out of my experience realm, and had to realize that like, I have to ask questions. I have to be confident that like, no matter what the question is, it's not going to be a dumb question. And I had to actually believe that, because I know we get told that all the time, no questions are dumb questions. I didn't believe that for a very long time, right? But I think it's just having that confidence that, okay, I can bring this up because I actually don't know, and again, being humble about it. And yeah, it's very simple, but maybe believe that. Yeah.
Thank you.
Thank you.
Just to wrap up our panel discussion this morning, I'd like to invite you guys to have any closing message for the audience today. Anything that you felt that you wanted to share but wasn't asked in a question. And maybe we'll start at the opposite end. Sarah, maybe we'll start with you.
Yeah, I always have 3 things that I always want to say is be curious, be bold and be courageous. It's okay to be scared. We've all been scared, and every day sometimes I still feel like an imposter. It doesn't matter what I'm doing. But to have the courage to face things, be curious and ask those questions and put yourself in different situations, that is a fantastic way to just tackle the world.
I think the biggest thing for me is seek out community. That's going to be one of your greatest resources, whether that be mentors in your community, whether that be peers that are interested in the same thing as you. And then further in that, going to conferences, going to things like this, finding those other women that can come alongside you and support you, women and men. But that's really important because those are the ones that are going to be there cheering you on, and those are going to be the ones that are going to be there when you do have those challenges, and they're going to get you back up on that horse as well. So that has been something that has been steadfast for me through high school, through my flight training, and now at Sunwing. And I know all us women here today too want to be a part of building that community for everyone here today as well. So yeah, really dive into that community, seek that out.
So as a professor, I'd like to leave you with a homework. And the homework is, I want you to learn about something called fixed mindsets and growth mindsets. And then promise yourselves, once you learn about growth mindsets and fixed mindsets, that you will adopt a growth mindset for your personal and for your professional lives. And that will make a huge difference.
Love it. Homework. I have 3 things as well. My 3 are always resiliency, honesty, and obligation to society. So from resiliency, as I mentioned, I'm sure lots of people in this room are going through tough things at home or in life or have something scary coming up, and just have faith that there is a light at the end of the tunnel for whatever it is you are facing. And if you can't see it right now, just do whatever you can to remind yourself that that is coming, because it will, I assure you. The second one is honesty. I'm a true believer that honesty is the best policy. Sometimes it's hard to be honest and tell the truth, but if you own up to the truth, it's again what we were mentioning about, gravitating towards authenticity. Lying will put you in crappy situations and it will be hard to get out of. And obligation to society, giving back is so important. And remembering that, for instance, maybe in an industry that's producing plastic and being we need a sustainable thing, and getting sustainability into it, instead of just being this industry sucks. It's how can I fix this industry? Or us doing things like this, giving back is great. And all of you are leaders in your own way in some capacity, and you can help other people follow the footsteps you've already walked in an easier way. And just if you constantly do that, if everyone constantly does that, we'll just have a better world.
Yeah. So much. So thank you. Let's thank our panelists again for sharing their time. I'll invite you guys to go back to your seats. Even though we didn't get a chance to hear all of the questions, I know there was a long line there. Again, I'll just repeat that in the atrium during the speed mentoring session, you'll get a chance to ask your questions one-on-one. Our final speaker this morning is Juliette Daniel. Juliette Daniel is a professor and cancer biologist at McMaster University. Juliette's research led to her discovery of a new gene, queso, coined from the popular Caribbean music calypso. Her team currently studies the difficult to treat triple-negative breast cancers, TNBC, that are most prevalent in young Black women. Juliette has been recognized for her research and youth mentorship by multiple awards, including the UWI Chancellor's Award, a Hamilton YWCA Women of Distinction Award, and a Harry Jerome Award. Please join me in welcoming Dr. Juliette Daniel.
Good morning. I'd like to thank the organizers for inviting me here, and I think you've all been sitting for too long, so if you want to just get up and stretch, wiggle some of the energy out, and then we can start. Because I was getting tired sitting, so. You're all like. Okay. Is he gonna, do I do the slides? Okay. So today I'm going to tell you a little bit of the story or of my journey from Barbados to a professor at McMaster University. And this is my tongue-in-cheek title. This photo is actually taken 10 minutes from my home. I grew up 10 minutes from the beach in Barbados, and this is where my family still lives. So I grew up in a low-income family in Barbados, even though we were living near the beach. And I was always fascinated with the human body, natural world. And my parents saw that I had potential. I excelled in math and physics, and sadly, no one encouraged me to become an engineer, no one whatsoever. Instead, they equated physics and math with becoming a physician. And so I was told, oh, you should do biology and become a doctor. So because no one in my family had actually gone to university, and there was no one to advise me, I said, okay, sure. And but the one thing I did know was I wanted to do research and to find a cure for some global disease. I didn't know which disease at the time, and to get the Nobel Prize. I had no idea how to achieve any of those things, but that was my goal as a teenager. So as a family, as I said, we were a low-income family. We didn't have money. We didn't have a car, actually, when I was growing up. We didn't get a telephone till I was 16. And yeah, this was pre-internet, dinosaur era kind of thing. And so basically, for me to attend university, my parents scrounged and saved every single penny they had so that if I wanted to go overseas to university, I could. And so when the time came for me to do that, I decided I would go, even though I was incredibly afraid and nervous because I'd never really left home or lived anywhere other than Barbados, and I didn't know how that was going to work out. But I had relatives in Montreal, and so I thought, that will be my safe haven. So one of the points I want to make here is that sometimes you just have to move out of your comfort zone to reach your full potential, because I really believe if I had stayed in Barbados, chances are I would have just gone to the local medical school and become a physician and not do the work that I'm doing right now. Because in Barbados, it's challenging to conduct scientific research just because we're a small island with only 250,000 people, not a huge economy or infrastructure to do biomedical research. But our current prime minister, who was a high school friend and classmate of mine, and the first female prime minister of Barbados, she wants to change that, and she has been on my case to change that since I was a professor. After 5 years of being a professor, she wanted me to come back and fix that. So we're going to work on that. So I made the trip from Barbados to Canada. As I said, I didn't know anyone. This was pre-internet. Had no idea what Canada was like. Thought it really was going to be lots of snow and igloos. Thankfully, it wasn't. I went to Queen's University, and another point I want to make is never underestimate, for any of the educators and leaders of academic institutions, never underestimate the way you treat people. As I said, I came from a low-income family. We didn't have any money, so I couldn't come to Canada to see the different universities. When I applied to the 5 or 6 universities in Canada, everyone sent me a little card saying, thank you for applying. But Queen's University was the only university that took the time to send my family and I an envelope every 2 weeks without fail with a map of Kingston. 2 weeks later, it would be pictures of the campus. 2 weeks later, it would be a newspaper from Kingston. 2 weeks later, it would be a newspaper from campus. Like every 2 weeks, we got some kind of information about Kingston and Queens. So when the time came to make a decision, my family and I, it was kind of a no-brainer. It was like, you're going to Queens. We have no idea what Waterloo looks like, or Guelph, or McMaster, or U of T. And so it's like, okay, I'm going to Queens. And so that's how I ended up at Queens. And basically, there I had a wonderful time. But again, because I came from a small island, I didn't know about all these different career options. Everyone in Barbados pretty much was encouraging young students to become doctors, lawyers, engineers, accountants, or high school teachers. Those were the 5 careers that all young students, regardless of gender, were being encouraged to pursue. And so I get to Queens, and I'm like, oh my God, there's all these career options. What am I going to do? And so these are some of the advice here, which I think I put in the wrong order. But anyway, so being an engineer was an option that I'd never, well, as I said, I hadn't thought about it because no one in Barbados told me or encouraged me to pursue that. I had friends that were studying pharmacy to become pharmacists. I learned about occupational therapy, physiotherapy, optometry, all these careers that I had never, ever heard of growing up in Barbados. Of course, we had heard about marine biology because we're on an island, and McGill had an actual marine biology station in Barbados, and it's still there. So we all thought we could be marine biologists. But all these other careers I'd never heard about. Being a bioethics lawyer, like that's something that's becoming quite hot and trendy right now, because with all of the big data that's being generated, all of the data being generated from 23andMe and Ancestry.ca, we're really going to need a lot of folks with different diverse careers to address all of these new avenues and careers that are developing that we didn't even think about or anticipate 20, 30 years ago. So physician's assistant is another one, a medical illustrator. Some of you might love art and you love science and you haven't figured out a way to combine those two gifts and skills that you have. Medical illustrator, all those beautiful pictures in your textbooks or slideshows, those are made by students, well, not students, people who love science and love art, but we don't have enough medical illustrators out there. So that's another career that you can think of. So there's just lots of careers. With the surge in artificial intelligence as well, that's as many, I think Vanessa is into robotics and that's another big career that's booming, but we're also seeing a huge need for folks skilled in cybersecurity with all of the data breaches that we're getting. So there's just so many career options, which is a good thing and a bad thing because it can also be incredibly overwhelming. And sometimes I say to my students who are overwhelmed with all this choice that I'm glad I'm not your age, because it really is sometimes too much choice and it can be really scary and intimidating. So, but as all our panelists just pointed out, you have all of us here to talk to. You have lots of other mentors, your teachers. You have way more mentors than you probably even appreciate. And with the internet as well and social media, you can reach out to so many people to get advice and guidance. So at Queen's, as I said, I was having a wonderful time, and then in my 4th year, everything kind of came crashing down. Vanessa kind of went through some of what Vanessa went through personally. So my next door neighbor in Barbados died of breast cancer. A month after that, my mom was diagnosed with ovarian cancer, and then 5 days before my convocation from Queen's, my mom passed away from ovarian cancer. So up until that point, I didn't know what I wanted to do. I was considering medical school or graduate school. And when my mom passed away, I kind of thought, I do not want to see a hospital. I do not want to see a single sick person. I do not want to have to tell a person their family member is going to die. So I kind of knew that, but I still didn't know much about graduate school, and the internet still wasn't around. But everyone told me the warmest place in Canada was Vancouver. And so sight unseen, didn't know a soul, I applied to UBC, packed up and moved because the novelty of snow had completely worn off by that point. So I packed up and moved to Vancouver, had a wonderful PhD experience there, made friends from all over the world. And at the end of that, I had to make a decision again, and I was still looking for somewhere warmer than Vancouver. So London, England wasn't really warmer, but I loved Europe, so I thought, well, maybe I'll go to London for a postdoc, or San Francisco, which I also really loved. And then I thought, well, maybe I'll go to the deep south where it's supposed to be blistering hot. And so I actually ended up in Memphis, Tennessee, against the wishes of most of my family because of the stereotypes of racism, etc. But I was, being this like trailblazer. How hard can it be? They can't be racist in 1994. Surely not. But apparently they still exist in 1994. And so my first 2 weeks were absolutely horrible. I was treated completely I got all the racist treatment you can get. I couldn't open a bank account, I couldn't get a driver's license, and I couldn't get my social security card. And it's only when I literally was sobbing at the bank and said, well, I just want to open a bank account and deposit $3,000. I don't want to take your money. She calmed me down and said, well, why do you even want to move to Memphis from Canada? And I said, well, I'm here to work at St. Jude Children's Research Hospital. And she said, oh, well, what are you going to do there? Are you going to be a secretary or a nurse? The typical response to a woman, and in my case, a black woman. I said, no, I'm a researcher. I have a PhD. And she goes, well, why didn't you say that? Here you go. And I was like, are you kidding me? Like this, wow. So that was my introduction to the South. But Memphis is a great place for a 4-day weekend, just saying. It is really a great day for a 4-day weekend. The Civil Rights Museum is there, which is built on the site where Martin Luther King was assassinated, and it is an incredible museum. And I would like to think that 25 years later, it's much better than when I was living there. So it was while I was in Memphis at St. Jude's Hospital that I actually cloned and discovered a new gene that played a role in cell-cell adhesion, which was the reason I went to Memphis, because I saw the opportunity there compared to San Francisco or London to work on a project that very few people in the world were working on at the time. So as I said, I really actually wanted to go to San Francisco, but I made the decision to go to Memphis because I was thinking long-term of my future career rather than short-term having fun in San Francisco, but then having to be really competitive for the rest of my life if I had gone to San Francisco. So I chose to go to Memphis specifically because I knew that it was a niche field and there weren't many people studying cell adhesion from the perspective that my supervisor was, and that I could possibly make some kind of discovery that I could then establish my own research lab, which fortunately I did. And as is mentioned in my bio, I cloned and discovered this gene. My supervisor had also discovered his gene, but he had named his gene just the molecular weight P120. So when I discovered my gene, he's like, please give it a really cool name because I regret just naming it after the molecular weight. So once I confirmed that I could call it absolutely anything I wanted, I said, okay, can I call it Kaiso, which is Caribbean music, and it's the slang for calypso, which is the music that I absolutely love. It's the music I played every single day. It's the music I pretty much converted the whole lab to loving. Even our Chinese technicians would play it on the weekends when I wasn't there. So it was very appropriate that we called it Kaiso after that. So I spent, as I said, 6 years in Tennessee, 3 years at St. Jude Children's Hospital, and then Al and I moved the entire lab to Vanderbilt University because there were more opportunities there. And then in 1999, I moved to McMaster University to become an assistant professor. And I've been there now 20 years running my lab. And it's the city of Waterfalls, so it's quite pretty. Just a little ad there. So in my lab, we study 2 types of cancer predominantly. We study breast cancer and colon cancer. And we also use molecular cell biology approaches, and we do some developmental projects using frogs, and we also use mice for some of our cancer work and also some of our developmental biology work. So as mentioned in my bio as well, at the moment, one of our major interests is a type of breast cancer known as triple-negative breast cancer. Breast cancers are actually classified and diagnosed based on the expression of 3 proteins or biomarkers: the estrogen receptor, progesterone receptor, and the HER2 or human epidermal growth factor receptor 2. Most breast cancers will either express estrogen receptor or ER or HER2, and the current therapies for breast cancer are targeting those 2 specific proteins. However, as the name triple-negative breast cancer indicates, triple-negative breast cancers do not express any of those 3 biomarkers, so there are no drugs that treat triple-negative breast cancers. So any woman diagnosed with triple-negative breast cancer can only have your standard chemotherapy and radiotherapy, but no specific therapy that will target the triple-negative breast cancer tumor. Those 2 therapies will just target any highly proliferating cell in the body. So what's really interesting and piqued my interest in this is the fact that it's most prevalent in young Black and Hispanic women. And unfortunately, most of the studies and the data on this come from the US, where they conduct and collect race-based data for all diseases. Unfortunately, here in Canada, we do not. But I think there's a push now and a recognition that we have to start collecting this data, because we're doing a disservice to some populations that may have predispositions to certain illnesses. So, as I said, I got interested in this, again, by going to a conference and hearing it at a conference and thinking, this is bizarre. And because I had always, as I said, wanted to do some kind of global research, give back to my community, and definitely give back to the Caribbean, I thought this might be an interesting project to study using my Barbadian population to see whether this subtype of breast cancer was prevalent in Barbados and impacting young Barbadian women just like it was in North America. So it turns out triple-negative breast cancer, the incidence in North America is about 22%, but in West Africa, Nigeria and Ghana, it's 50 to 80% of the women there have this type of breast cancer. And since there's no treatment, that means the mortality rate from this is really, really high. So I have this little poster on my door to remind me every day that this is a motivation for doing this as well, to make sure that, you know, your children and you guys, ladies will not have to deal with a diagnosis of breast cancer. So at the moment, we're collecting, or we have collected tissues from women in Barbados, in Nigeria, and Jamaica, and we're using those tissues to look at the expression of Kaizo, which, as it turns out, is highly expressed in triple-negative breast cancers, not just from Black women, but from any woman that has triple-negative breast cancer. But there is more Kaizo in Black women than there are in Caucasian women. And that's something that we're trying to understand, whether Kaizo is driving that high incidence and mortality rate in Black women compared to Caucasian women that have triple-negative breast cancer. So everyone's talked about their journey. And I tried to make this quickly last night. It's not, I'm going to remake it next time. But just to show you that none of us, I don't think any professional that you see or you encounter has had a journey that looks like a nice straight line up to the top. And if they did, then kudos to them. But this is pretty much to show you that, you know, everyone's journey is complex, and we've had ups and downs and challenges. And and what you're seeing here, and it's my next slide, is basically this iceberg illusion, which hopefully you've seen before, and if not, hopefully you'll take a good look at it. That many of you see us here, and you see other successful people, male or female, and you're thinking that could never be you. And as I said, like many growing up, I never thought that I would be a professor at a Canadian university. I definitely never thought I would be standing on a stage speaking, because I absolutely hated public speaking, like absolutely hated it. So much so that during my PhD, when I had to do my comprehensive exams, I actually failed the oral component of my comprehensive exam because I answered every question with a question. So they would ask me, I'm just going to make this really simple, what color is the sky? And I would say, the sky is blue? And then they would say, okay, can you tell me how many fingers you have? Maybe 5? Every single question I answered that way. And so they made me repeat the oral with confidence. And by that point, I was really pissed and angry, so I did. Because everyone else that failed some component of their comprehensive got to do a written submission as their makeup. But they insisted that I was the only one that had to do an oral because it was about my confidence and not my knowledge. So again, this is part of my squiggles. So what you see in front of you most of the times are just folks that were able to overcome those challenges, build resilience, and fight through everything to get to where we are. And it's not easy even being here. For 20 years, I've been the only Black female professor, Black female scientist at McMaster, and that has been exhausting because students hear about me and find me, and I'm learning to say no. It's hard because they're very, like many of these students want to be encouraged. They've never seen a Black professor. They've never had a Black female professor. Like, it's just, I'm like, I don't know, a unicorn, I guess, to them. So it's tiring sometimes, but I want to do it because I want to see more diversity in science, because many of these students have so many skills and talents and gifts. And some of them are so creative and way smarter than I was at their age. And so I'm trying to encourage them. And So finally, these are tips that I give to my students in my classes. So this is one that I encountered recently that I really like, tips from an eagle. So try to soar to new heights whenever you can. But like an eagle, just keep an eye on what's happening around you, ahead of you, everywhere. Swoop down when you can on any opportunities that you see that you think would be worthwhile, and I'll rise above all the challenges, the negativity that you may encounter, because you will encounter it, especially if you're ambitious. Ambitious women tend to encounter more negativity than their peers that are males. So that's just the reality that we have to accept. And it just means we're smarter and tougher because we survive. And spread your wings, find a career where you're going to thrive and really excel and be happy. And as I said, if you find that you love 2 or 3 different things, think about a way to marry all of those things into a new career, because, as I said, bioethics law wasn't something that existed before. So there are careers that don't exist now that will exist in the future, and maybe you could be the pioneer, the trailblazer for that particular career. And one of my favorite quotes is, it's your attitude and not your aptitude that determines your altitude. So I've had students that were really, really gifted and smart, but they had such negative attitudes that the experiments never worked. And then I've had students that were so positive, so charismatic, that their experiments worked because They came in thinking everything would work, and again, like Hin said, it was about mindset. Their mindset was completely about growth and problem solving, and rather than negativity. So this is one of my favorite quotes for all my classes. And along the way, you have fun and you get to interact with a bunch of really cool young people as a professor all the time. This is our team, Pirates of the Caribbean. We run and raise money for breast cancer. So this was us at the local Hamilton run, and I will end there and take your questions.
We have time for one question.
One question.
We're kind of...
My name is Jill. Do you ever find it discouraging to work with something as complex and challenging as cancer?
It's not discouraging because, as I said, I've lost so many people to cancer, and I myself am a cancer survivor, so it's not discouraging. Like, that actually motivates me. And when I was at St. Jude's Hospital, actually, that was also, that further fueled my passion, because the way St. Jude Children's Hospital was set up, the research floors were on the 4th and 5th floor, but everyone entered the hospital through the same doors. And St. Jude focused on children's cancers, leukemias, lymphomas, etc. And every single morning when you went to work, you had to pass all these little kids and their families waiting. And it was kind of like, if your experiment didn't work the day before and you walked in, you're like, okay, this is why I'm doing this. So it's actually not discouraging, because you know that you're really trying to cure something that has impacted so many families and so many children, that it's not discouraging. What's discouraging is how our current system of academia is set up, where you have to apply for funding to do this research. So that rather than doing the research, you're constantly writing grants and getting rejections, and writing grants and getting rejections, and not doing the research. That's what's the most discouraging part of being an academic cancer researcher. Yeah.
Thanks.
You're welcome.
I'm just going to ask the speed mentors to make a quick exit, just as we're offering thanks again to Juliette for the lovely and very inspiring talk. Again, we've covered a lot of territory today, and I hope that you'll also have the chance to interact with the speakers that we didn't get a chance to ask as many questions as we would like in the atrium later. Feel free to share tweets and posts about your favorite moments online using @Perimeter on Twitter or PI Outreach on Facebook. As we close, I would like to thank again Linda Hasenfratz for her participation today, and for Linamar's Corporation's ongoing support of women in science as presenting sponsor for this event.